doing the axis of symmetry was a good spot to jump back in because it's something we've been introduced to. Okay, it's that line, that dotted line that goes through the middle of our parabola. Right. But we're also going to have a new way of finding the axis of symmetry without knowing the vertex or having a graph. So, the parabola, again, is symmetric, which means it's like a mirror image. Okay, symmetric. It's like it's a reflection of itself on both sides. With respect to this dashed vertical line that contains the vertex. So, for instance, if I drew myself a little sketch here, and again, no rhyme or reason, I'm just making me a parabola at this point. And I know that the vertex is right here. Okay? Wherever that vertex line is, well, excuse me, that vertex point is, there's a vertical line that goes through there. Where if I were to pick up my paper and fold it along that dotted line, it'd be the same on both sides. This is called my axis of symmetry. And if I'm making the equation for it, whatever x value that dotted line is going through, that's where my axis of symmetry is. Now, I'm not going to put AOS equals 2. I'm not just going to stick a 2 there. I've got to have the x equals because that tells me that it's a vertical line, that someone's looking for it through there. So this is always the way we've done it. I've either known that that's the x value of the vertex, which we'll talk about again here shortly, or I've been able to look on the picture and just see that it's there. So now, so again, if I see this, I could be like, all right, right through the middle. Now this is really faint. We're going to have to kind of guesstimate here. Looks like -1, looks like -2 to me. So I get that point. I know, I was kind of guesstimating on those because my grid lines did not come through fantastically on that whatsoever. And so, if I don't have a picture though, how would I find the axis of symmetry? There's this little equation that we can use called -b, or the opposite of b, over 2a. And so when I'm looking at an equation in standard form, the number in front of x squared is the a, the number in front of x is the b. Those are the two things I need to keep track of. But here's the fun thing to note. This also is going to tell me the x value of the vertex. When we've had equations in standard form, we've always typed them in and then we've had to scroll up and down in the chart until we saw the symmetry. Now, with the values, I can just plug them into this, get the x value, and just go to that in the chart. I'm not having to search around. So it can make things go faster. And then I can plug the value in to find the y if I need to. So, for instance, okay, without graphing, okay, find the axis of symmetry and the vertex. First thing, yes, that is a negative there. So my a would be -1. Wish we'd had that negative a little bolder. We'll make it so. My b is 6. And if I needed c, I'm going to go ahead and label it. My c would be -5 because I'm just following a. Number in front of x is b. Number hanging out on its own is c. So we're going to follow this formula. The opposite of b, the opposite of 6 is -6. Where's this coming from? Yep. 2 parentheses negative 1, because we got to multiply those together. So now, here is one thing that I would suggest doing when you're doing these. Because sometimes, not every time, but sometimes it can make a difference if you just try to type all this in. So, I'm going to multiply these two together first. Two times negative 1 is negative 2. Then let the calculator help you. Negative 6 divided by negative 2 is positive 3. Yeah, we're just looking with A, B, and C. We just want the coefficients, the numbers in front. Nope. Because I can still find C. There are other uses for the C, not in what we're doing currently. But I want you to get used to seeing that it's there. But yeah, we don't use it in the formula at all. So once I figure out what x is, that's the axis of symmetry, okay? So I just found out the axis of symmetry and the x value of my vertex. But you're like, but wait a minute, I don't know what y is yet for the vertex. So I have two options, and I will write them both here so you have both options. I could do, one option is to take y equals, and what I would do is I'm going to start copying this, and every time I get to x, I'm going to replace it with a 3. So I'd be able to go to my calculator, and I would just type this in. Once I plugged in the numbers, so all I did was I took the 3 that I found in the x, okay, and I just plugged it in for x in the original equation. So I just took the original equation and started writing it, and every time I saw x, I would plug it into the equation. So I could do this. I could find my vertex and my axis of symmetry without having a graphing calculator. Now, does that mean that I can't use the graphing calculator? No. Like, I could still go to y equals, and I could still clear things out and just type in what's here. Negative, again, here's my x. I know it's been a while. Hopefully we got this in the notes. Here's my button here for squared, right kitty corner to the 7. Plus 6x minus 5. And I can do my chart, second graph. Now, if I wanted to, because I already knew what x was supposed to be, 3, check it out. Boop, go over to y, it's 4. So I can use the table to find y as well. I don't have to, once I figure out what x is, I don't have to plug it back in like this. It works, but if you want to, you can go to the calculator, type in the equation, go down to your x equals number and find out y that way. And you've got your vertex and your axis of symmetry. So it's just one of those things where you have multiple options now. You can do it the algebra way or you can do it the calculator way. Oh my gosh, a word problem. Look out. We got a frog, people. A frog is sitting on the ground when he's scared by a dog. I don't know where the dog is here. His movement is modeled by the equation h equals negative 6t squared plus 6t. How many seconds after jumping will he be at his maximum height? Okay, so here's the thing. So this is going to be, whenever we talk about time, we're going to be looking for the x value. And when it says maximum, that's going to be at the vertex. So let's play here. Back to y equals, we'll clear things out. I know that says h equals, but y equals works for this. And I'm going to just use x for the t's. So I get those typed in. I can look at the graph if I want to. I'm kind of curious this time. Okay. So here's our parabola. Our frog's jumping up, coming back down. So I want to know what the maximum height is. So I can either go straight to my chart and start looking around. Now here's the interesting part. I start looking around and I'm like, well, wait a minute, Hardy. I see, 72, 72, negative 36, negative 36, 12, 12, 0, 0. Where's the number in the middle that's the oddball? That's kind of weird. So if I run into that situation, and I did this time, let's come back up here and be like, all right, let's try the math way. So here, a would be negative 6. That's the number in front of squared. Our b value would be positive 6. Okay, that's the number in front of b. So I'm going to use my formula. Let's see what happens. So the opposite of b, negative 6, over 2 times a. Okay, let's figure this out. So 2 times negative 6 is negative 12. Negative 6 divided by negative 12. Ooh. Half a second, 0.5. Oh, this makes sense now. Okay. So it took him half a second to get to his maximum height. This answers why, when we looked in our chart, we didn't see the oddball number, because we only see whole numbers here, and it was a decimal. Oh, that might be why it's good to have this as a backup plan, because the calculator only does whole numbers, and sometimes, we may get a number that's not a whole number, and this is a good option for us. So what do I do then in this case? Well, in this case, okay, I'm going to show you 2 tricks, so get ready. My first one would be, again, I'm just going to start recopying this until I get to the t's. I am going to show you a calc option here in a sec too, though. So one way would be I get back out of there and I just type this in exactly like I see it. Make sure you get the decimal in there. We get the squared in there. And I can find my height. Now, there is an option. I'm going to show you. I'm not going to write a ton about it on here, but if you kind of play with it and see it, this will work. So if I'm back in here, I can plug in any x value to this equation I want and find out what y is. So check this out. If I hit trace, you can type in, you're supposed to be able to type in, let's try this again. Why is this being funky? Okay, the calculator's decided to go cuckoo on me. You're supposed to be able to hit trace and just punch in any value you want, but my calculator is like short-circuiting on me. Okay, now I look like a liar. Well, that's all right. But this would be the way that you would be able to find that out. Just plug the number back in. Let the calculator do its thing. See if I can find another calculator that wants to do this correctly at some point. So, I'm going to keep this close, because especially for the formula, I'm going to want it. I don't need all my other notes yet. So I'm going to move over to the practice. And I'm like, this is basically going to be like what we were doing before. But we're going to throw a little review in as well, which is helpful, because we haven't been together in a while. So, draw the axis of symmetry, which again is just an x equals. and give the equation of the line. So, I mean, again, it doesn't matter where you go. Let's even say at number 3, because this might be a little weird. Okay, so here's my vertex. What's my x value at that dotted line? Where am I going through the x-axis at with this? 0. That's all you need. Draw it in. Put your x equals 0. Now for this group down below, and again, it can vary up for us a little bit. We can have something that's really straightforward, like let's say number 5. Looks pretty straightforward. If you don't see a number in front of a variable, there is a 1 there. If you see minuses or negatives, those are included. Formula's right here for me. Got to remember that opposite part. So switch the sign up on B over 2 times A. Again, if you're going to the calculator, always, always, always do that part first. And again, I think we can handle 2 times 1, so we will not go to the calculator on that. So I get my x equals 2. And now for y, again, you have a choice. You can either plug in 2's for all the x's, oh, when we get to the end here, I'm like, what did I do wrong? Okay, I haven't done anything wrong, at least as of yet. As of yet. I always got to put the disclaimer out there because it does happen. I'm not going to say that it doesn't. -1, I'm with you. Or again, if you get worried that you're going to type something in wrong or something like that, you can go to the y equals. You can absolutely do this. And once you know that x is 2, just do second graph, go to the 2, and there's the -1 that we just found. Yep. Yep, it's always over 2a every single time when we're trying to find that x value. So even if you do run into something, let's say like number 9, we'll do one more, just to kind of make sure here. You're like, those are some big numbers. Yes, they are. So again, we do the opposite of B. If B would have been positive, we'll put a negative up there. The opposite of B over 2 times A. Again, if you're going calculator mode here, do the 2 times -2 first. Then do your division. There is your axis of symmetry and the x value of your vertex. And now again, totally up to you. If you want to do it like I'm doing it right now, or if you just want to go ahead and type in. I'll do both just because, you know, that's what I do. Let's double check me. We'll retype that in. The only time with all this minus negative stuff that I use the negative is the very first number in front of x squared. The other ones are minus. Let me find -5. There's my 4. I got it. I got it. So just more tools for our toolbox as far as the axis of symmetry stuff goes. Nothing that's going to be too bad. It's a nice way to kind of work back into things. Now, when we get to the back, just a couple back here I want to touch on. So this is kind of like our frog problem. It might be a nice number. It might not be a nice number. It just depends. So we've got our equation. So my A is negative 16. My B is 96. Number in front of the squared is A. There's B. Find the time for the rocket to reach a maximum. Time maximum. Find the x value of the vertex. In other words, use the opposite of B over 2A formula. Okay? Time is always x, no matter what. So, the opposite of 96 is negative 96 over 2 times A. So just to show you something, you're like, why do you keep saying we got to do the bottom first? So let me just type it this time and not care. I don't think my vertex is at 768. That doesn't make much sense. So that's why I say we want to make sure. Now, could I type it in such a way with parentheses to let the calculator know what to do? Yes, but I think it's going to be easier. Okay, so it's going to take 3 seconds for that rocket to get to its maximum height. And then the maximum height is always going to be y. So, again, I have an option. I can either go back in and plug in 3's where in this case the t's are at, or I'll show you in a second here, again, how we can just do it in the y equals on the calculator. It really doesn't matter which one you do. So no matter if I plug it into the formula, or I plug these in, again, we just use x instead of h, but they work the same way. I pull up my chart, I go looking for 3, I look at the y, they're the same thing. Same formula, just a different way of seeing the original problem. And that's all we're going to do up there. And then to wrap her up, what is the vertex of the following functions? Now, I have notes for this. I'm going to write something anyway, but I do have notes for this. Okay, when we're looking for the vertex, it's just those 2 values to find it. So when we're trying to find h and k, I'm just going to rewrite this for a second so we can see it. I'm paying attention to these 2 things. So if I want the vertex, here's the kicker though. We do the opposite of h. The opposite of negative 3 is positive 3. The k, whatever number's out here, whether it's positive or negative, I just keep it. That's it. Now, are there going to be some curveballs that get thrown at you? Yeah. Well, Hardy, what if there's no parenthesis there? Okay. That's the same as me having this. It's just like saying it's x minus 0 squared. Or Hardy, what if there's no number on the outside? Again, there's just going to be a 0 there. We just got to keep reminding ourselves that and working on that some. So then my last thing for you. Way back to the radicals, but hey, we got this. We've got to get, okay, we've got to get the radical alone. The radical? Yeah, the radical alone before we square it. Number 5, I can square right away. It's already alone. But I don't want to do that one because that's the easy way out. So we're going to do 6. My first job before anything is to get that radical alone. I'm multiplying it by 4. I got to do the opposite of that to both sides. So on this side, the 4's just cancel. 8 divided by 4 is 2, because what we do to one side, got to do to both. And once that radical's alone, the only way to undo a square root is to square it. Both sides, not just the radical side. And 2 squared, 2 times 2 is 4. And you just have a one-step equation now. It's been a little while, but it'll get back into the swing of things. So your job is to finish off this 13 and 14, and like I said, tomorrow we'll get back into the graphing of both types of ways again, just to kind of get us some reminders and make sure our notes are in good shape and stuff like that. Speaking of the notes, I will say one